In this lesson, we're going to export an STL file. After completing this lesson, you'll be able to create an STL file and modify file export settings. In Fusion 360, we're going to start with the supplied dataset microclass chassis-RTP. The RTP stands for Ready to Print. And as we take a look at this file, we'll notice that we have four components: a motor guard, landing gear, a camera mount, and the main chassis. We're going to be working mainly on the main chassis, so let's right-click and select Isolate, which will hide all the other components. We want to send this out to an STL file so it can be 3D printed. When we're talking about sending a file or exporting it as an STL, there are several different areas in Fusion 360 where we can make this happen. All of them will produce the same results, so we're going to explore the different access points and then we'll go through the process once. First, when we right-click on the component, the main chassis, notice that we have an option that says Save as STL. If we click on that, it's going to open up a Save as STL dialog box, and you can see that we get a preview on the screen of the mesh. I want to note a few things in here. We have refinement options, which we can expand, and then there's an output option that says Send to 3D Print Utility. We're going to explore all of these options shortly, but for now let's hit Cancel. If we expand this and expand the Bodies folder, we can also right-click and notice that we have Save as STL for the body. In this case, because there's only a single body in the component, it's going to produce the exact same result. If we right-click at the top level, notice that we also have Save as STL. Keep in mind when we do this, we're talking about all the components and bodies in the design. The output looks a little bit different because now we have one file or one file per body options. So in this case, since all of these parts would need to be printed, this might be a valid option to export all of them to individual files. But we would need to keep in mind that things like the motor guards, there are 4 separate bodies, but in reality it's the same part, so likely you'd only export it once. In order to do that, you'd have to expand the bodies and components, and then isolate just one of them and save as an STL. We also have other areas, such as the File dropdown. When we select the File dropdown, notice that we have options to Save As and Export. If we select Save As, this is going to prompt us to save the file in the cloud. If we select Export, we have the option to change the file type and export it locally. While we're looking at the file types in here, notice that we have an OBJ file and an STL file. There's also other types of file types in here, such as STEP, SMT, and SAT. But using the STL file type option will allow us to, again, initialize the STL dialog box and begin creating that export. There are also tools that are located on the Tools section of our ribbon. Inside of here, there is a Make option, and the Make dropdown has 3D Print. When we select 3D Print, this is the exact same Save As dialog box that we had before. For example, if we show the motor guards and I select the main body as well as one of the motor guards, notice that it's not allowing us to select multiples. But it is still giving us the same Save As option for exporting this 3D print. The main difference when using the 3D Print option under the Make dialog is that it automatically checks the Send to 3D Print utility. You can pick a 3D Print utility that you have installed on your machine, or you can select an application. If you select none of these options, you'll be prompted to save this file locally. So let's cancel out of this one, go back to the solid menu, and let's focus on the original option that we selected of right-clicking on the component and selecting Save as STL. When we do this, we're working with this single body. And if we zoom in, we can see the STL mesh that's going to be created. By default, we're going to preview that mesh, and the format is going to be binary. From here, the one file option is deselected because we're only dealing with a single body. The number of triangles is shown, and then the refinement options that we have are high, medium, low, and custom. If we select low, it'll update the screen and we'll see the new mesh display. This is a relatively small part, being under about 5 inches by 5 inches. So we would need to make sure that we capture enough resolution to get all the features that are needed, such as the small holes. But keep in mind that there is going to be a break-even point where the higher resolution isn't really going to produce any higher results. So make sure that you understand the capabilities of any printers that you have access to and really what kind of resolution they're looking for. If we set this to high, the number of triangles in the file and ultimately the size of the file are going to be quite a bit larger, and most desktop machines likely won't be able to make use of it. If we zoom into a certain area, such as this fillet, or even in the small fillet around the motor, we can see that we have a lot of small triangles based on that resolution. If we set the refinement to custom, we have a little bit more control over these refinement options. For example, the normal deviation, the maximum edge length, and the aspect ratio. Making adjustments to any of these will make adjustments to the preview on the screen. So my suggestion is to turn off Preview Mesh. If you have a good idea of what these settings do, make adjustments to it and then turn the preview back on so it's not trying to recalculate every time you make that adjustment. You can also see what these numbers are when you navigate between the different refinement options to get a good idea. For example, if we go to the high refinement option, you can see the surface deviation value is extremely low, the normal is set to 10, the maximum edge length and aspect ratios are on the upper scale, but that's 14,000 millimeters and 21.5. If we set it to low, notice that the surface and normal deviation values go up, while the other values stay the same. So once we're happy with the results and we have a file that we're ready to export or send directly to a 3D print utility, we simply need to say OK, and then we need to pick a location to save that file. It's a good idea for you to play around with this and bring these STL files into your print utility and get a good idea as to what these resolutions mean for your final prints. Anytime somebody is using a design tool like Fusion 360 for the first time and sending these files out to a 3D printer, I like to suggest that they make a sample file. Print a small part that has some curvature, some different geometry on it, send it out in different resolutions, make a 3D print, and identify what that means for you. For a print like this on a small desktop printer, this could take anywhere from 4 or 5 hours at a low resolution up to over 15 hours with the extremely high resolution if the printer can handle it. So it's not a good idea to waste that much time sunk into a specific print if you're not sure what the resolution values will be. From here, we haven't really made any changes to the file, but let's save it just for good measure before we move on to the next lesson.